In this video, I am going to look at how to find the equation of the normal to a parabola, both in Cartesian, using Cartesian coordinates and parametric coordinates. Very similar to my last video, we are going to start first with the Cartesian version and second with the parametric version. The steps are almost identical, so it's good practice to go through it and you get to see everything a second time. So let's write our question down. Okay, so again, to find the equation of any line, I need a point and a gradient. I have a point x1, y1, I need the gradient of the normal. So let's write a little heading, gradient of normal. To find that, I need to differentiate. And notice, even though I've just done this, and I've done this many times, every single time I start from first step and communicate. So before I can find the gradient of normal, I have to find the gradient of tangent. Therefore, gradient of normal is negative 2a over x1. Now I find the equation of the normal. And note, again, I am going to write my formula down. And I'm going to then substitute in. Lucky for me, x1 and y1 substituted in already. So at this stage, I can rearrange to try to get the same equation as it might appear in the question. But I am going to stop at this point and move on to the parametric version. So as with the tangent, we are going to find the equation of the normal. As before, first step, gradient of normal. We start with rearranging. Then differentiate. And then substitute in x to find gradient of tangent. And I can even write gradient of a tangent at P equals 2AP over 2A, which is equal to P. Therefore, gradient of normal is equal to negative 1 on P. Now I can go and find my equation. And then I am going to rearrange. So I end up with py minus ap cubed equals negative x plus 2ap. So py plus x equals 2ap plus ap cubed. And again, I can rearrange, I can factorize. It all depends on what we're trying to achieve and what the question wants. Note that in all four cases, the method was identical. The question has asked for an equation of a line. To find the equation of a line, you need a point and gradient. And we find the gradient, use the point, substitute into y minus y1 equals m outside of x minus x1. And that's what you need to remember to answer these questions.